In this problem, it says that we have a rotating light on top of lighthouse and sends rays out in opposite directions. So it's sending rays out in this direction and this direction. So angle theta makes a spot of light that moves along the shore, and we're going to call that distance d here. And it rotates every 2 minutes. It says determine an equation for that expresses the distance as a function of time. So we know that the distance over 500 is going to be equal to tan of the angle theta, and we want to change that into time. So we need to say that, well, since k is equal to 2 pi over t, and although we sometimes use the period of tan as just pi, because this is going in a full circle, we're going to use the 2 pi as a period of this. So it's going to repeat itself. This end of light is going to repeat this end of light. So we're going to do the full circle. So we need to change our period here to 2 minutes. So the k value then is going to work out to be 2 pi over 2 minutes, which we'll just say is pi. So then to get the time, we're going to change this into pi times t. And that will give us our angle. So at 2 minutes, we're going to be 1 full circle, or 2 pi. So that's our expression. We're going to then solve this for d, and make this a function of time. So it's going to be 500 pi t as our function. And then when we graph this is just going to be a tan function, and it's kind of hard to show the expansion, but it's going to go up to its asymptote at 90 degrees, or in this case it's going to be 30 seconds, or 0.5 minutes. Okay, so that's going to be 0.5 minutes, and then it's going to come from the other side. So d is going to be negative. It's going to come from the other side like this. Is going to be at 1 minute. This is going to be at 1.5 minutes, and then again the function is going to come around like this and just keep on repeating itself. And that will be 1 full cycle from here. From this point here to this point here is going to represent 2 minute cycle. So part C, explain the significance of the asymptote of the graph when theta is equal to 90 degrees. At 90 degrees, if we take a look at this light, it's going to be pointing straight up this way, and the d value will never actually touch this wall. So d will be infinite. So that's what's happening out here at 90 degrees, okay, which is at 0.5 minutes. It's going to be pointing up towards infinity, because this line at 90 degrees will never touch that wall.